In this example, we're having a look at error propagation. We're told that a cylindrical sample of titanium is weighed using a top pan balance and its mean diameter is determined using vernier calipers. The following results are shown. The mean height of our cylinder was 1.84 centimeters. Its mean diameter was 0.42 centimeters. Its mass was 1.16 grams. And we've been asked to calculate the density of titanium in both grams per centimetre cubed and kilograms per metre cubed, the percentage uncertainty in the density, and the absolute uncertainty in the density. So if we start off by calculating the density of titanium, we know that density is equal to mass over volume. We know in the question what the mass is, it's 1.16 grams. But we need to calculate the volume. Now the volume of a cylinder is equal to pi r squared h, where r is the radius of the cylinder and h is the height. Now in the data given we have the height is 1.84 centimeters, but we're given the diameter where we require the radius. But recall that the radius is simply half of the diameter, so we can say that the radius is 0.42 divided by 2 to give us 0.21 centimeters. So using all of this information we can calculate the volume. Volume is pi r squared h, which is equal to pi times 0.21 squared times by the height, which was 1.84. And using my calculator I found that to be 0.25 and the units are centimeters cubed. Therefore now to calculate the density, it is equal to mass divided by volume. The mass was 1.16 grams and the volume was 0.25 centimeters cubed. So subbing that into our calculator we're going to get an answer of 4.55 grams per centimetre cubed. So that's our density of titanium in grams per centimetre cubed. The question has also asked us to convert it into kilograms per metre cubed. So recall that to convert grams into kilograms we need to multiply by 1 times 10 to the minus 3. If we want to go from centimetres to metres we need to multiply by 1 times 10 to the minus 2. Therefore as we're going from centimetres cubed to metres cubed we need to multiply by 1 times 10 to the minus 2 to the power of 3, which gives us 1 times 10 to the minus 6. So using all of this information we can calculate our density. So recall we found the density to be 4.55 grams per centimeters cubed. So if we want to convert grams into kilograms, recall we multiply by 1 times 10 to the minus 3. And then we're going to divide by centimeters cubed, but we want to change that into meters cubed. So on the bottom we need to multiply by 1 times 10 to the minus 6 to get it into meters cubed. So by subbing all of this into our calculator, so we'll get 4.55 times 10 to the minus 3 divided by 1 times 10 to the minus 6, we'll get an answer of 4,550 kilograms per metre cubed. So we've actually found our density in both grams per centimetre cubed and in kilograms per metre cubed. We are now required to calculate the percentage uncertainty in the density. So to calculate the percentage uncertainty in the density, we first of all need to calculate the percentage uncertainty in the mean height, the diameter and the mass. So if we recall how we calculate percentage uncertainty, we take the absolute uncertainty, which for the mean height is 0.02, divide by the mean value, which is 1.84, and then we multiply by 100 and we'll find an answer of 1.09%. So the percentage uncertainty in the mean height is 1.09%. Repeating that for the diameter and the mass, we'll find the percentage uncertainty in the diameter will be 0.02 divided by 0.42 multiplied by 100 to give us an answer of 4.76%. It should be noted at this point that the percentage uncertainty in the diameter is also the same as the percentage uncertainty in the radius. And that's simply because to go from diameter to radius we divide both by 2, so we'll actually end up with the same calculation. So percentage uncertainty in the diameter is the same as the percentage uncertainty in the radius. For the mass, the percentage uncertainty will be 0.01 over 1.16 multiplied by 100, which will give us a percentage uncertainty of 0.86%. So, to calculate the percentage uncertainty in the density, we need to recall that density is equal to mass over volume. And when we do division, we have to add our percentage uncertainties. So it would be percentage uncertainty in our mass plus the percentage uncertainty in our volume. Now the percentage uncertainty in our mass is 0.86%. So we can add that in immediately. Value here is 0.86%. We do though have to do a little bit of work to find the percentage uncertainty in the volume. Now if we recall volume with pi r squared h. Now let's think for a second what we're doing. Well, pi is a constant, so we don't need to concern ourselves with that. But we have an r squared and a h. Well, these are multiplying each other. And recall that when we multiply, we have to add the percentage uncertainties. So we'll have the percentage uncertainty in the volume to be the percentage uncertainty in r squared plus the percentage uncertainty in the height. But as r squared is simply r times r, it's still multiplying. So the percentage uncertainty in r squared is simply going to be the percentage uncertainty in r plus the percentage uncertainty in r again, because it was r times r, plus the percentage uncertainty in h. Now we have all of these values. We know the percentage uncertainty in the diameter was 4.76%, so that's the same for the radius, so that will be 4.76 plus 4.76, and the percentage uncertainty in the height was 1.09. So we can see the percentage uncertainty in the volume is going to be 10.61%. Therefore, the percentage uncertainty in the density is percentage uncertainty in the mass, which was 0.86, plus the percentage uncertainty in the volume, which was 10.61, to give us an overall percentage uncertainty of 11.47%. So that 11.47% is the percentage uncertainty in the density. The final thing we need to calculate is the absolute uncertainty in the density. So if we recall how we work out percentage uncertainty, it was the absolute uncertainty over the mean value. Now we have the percentage uncertainty and the mean value, so to calculate the absolute uncertainty, we simply take the percentage uncertainty and multiply by the mean value. So for our example, it's going to be the 11.47%, so we'll have to divide that by 100, and then multiply by the mean value, which if we take the grams per centimetres cube unit, it will be 4.55. So by substituting that into our calculator, we'll get an answer of 0.52 grams per centimetre cubed for our absolute uncertainty. So I could write down my final answer to be my density is equal to 4.55 plus or minus 0.52 grams per centimetre cubed. Thank you for watching.